Hello everyone, welcome to Reach Goals. Today I'm going to talk about system design of Indian Railway Reservation system, and I'm going to talk more about microservice architecture with the distributed transactions. So if you're answering in the interview or if you really want to talk about system design steps, you have to talk about four important things. One is the scope, and the second one is the key components and the database model or the database design. And finally, you have to talk about scaling for the demand, right? That's how you build a robust system design, right? When you talk about scope of the design, you have to clearly articulate what you are going to include in the system design and what you are not including in the system design, right? So here I'm going to talk about how to create the inventory or the tickets. Then I'm going to talk about booking the tickets. In that, I'm going to cover two important things. One is distributed transactions in the microservices, and the second is how to avoid duplicate bookings or the concurrency in the system. We will also cover how to create user accounts. Then we will talk about how to search the trains with the PNR or based on the starting and ending locations. We'll also cover how to view the train details, and finally we'll talk about how to cancel the tickets, right? Here let's talk about pseudo APIs. Before going into the APIs, let's understand how this flow works, right? So you go into the any reservation system, then you create an account, then you search for the trains, then you'll see the list of trains, right? After that, you select any of your class, whatever you need, and you see the details of the train, right? Now you have an option to book the tickets, right? You give all your information like, the first name, last name, and your phone number, etc., and you book the tickets, right? Now, next thing is you get a notification saying that your ticket is confirmed or it is waitlisted, right? That is a basic flow you see in any reservation system, including the railway reservation system as well, right? So let's talk about the pseudo APIs, right? So the primary APIs required for the system is you have to create an account, right? For that you have an account service where you have parameters like app key, username, password, and the address. The second thing is you need to do a search service, right? In that you have app key, then you give a starting location, ending location, and the date you want to travel, and the class of a train, like first class or second class or the general compartment, whatever you want, you give that, right? Then you give a search. And the third API is detailsService. This is like you look for a specific class and you see what the detail about the train is. Something like how far the train has to travel, what is the departure time, what is the arrival time, etc., right? Those things can be achieved from this service. And the fourth one is booking service. This is a very important service which involves the distributed transaction, right? So when you start to book a service, you give the informations like at what location you have to start, at what location the train has to end, and you give an information on the date of travel and the class, right? So that's where the booking ends, correct? Now, the other services are payment service, then you have a service called notify service, and you also have service called cancel service. In this, if you see, the payment service and notify service are internal services and they are not exposed directly to the customers, right? So internal service like booking service might call the payment service or notification service internally, right? So this can be easily mapped to the flow whatever we have seen on the top, right? You can easily map to each and every flow from the top, right? So that's how you create an API based on the flow, right? In this section, let's talk about database schema for railway reservation system, right? So since this is a microservice based architecture, I'm going to have three different schemas, right? Keep in mind it is three different schemas, not the three different tables, right? The first one is user DB, where it will have the information related to the users, right? So something like you will have user ID, name, email, phone number, username, and password. Typically in a real-time system, you will not see the password in the database. Mostly it will be stored in the LDAP or some other server which is highly secure, right? The second schema is inventory table, right? So inventory table is something which you have all the information related to the ticket. It is kind of a product where the railway department is trying to sell to the customers. It's a very big table or a gigantic table where it has a lot of information related to each and every ticket or each and every legs, correct? So it will have informations like inventory ID, train number, from where this train starts, where the train lands, and it will also have the departure time, arrival time, the distance to travel, and the time taken for travel, etc. And also it will have the primary informations like what is the class the passenger is going to travel and the price of each class, etc. Right? So that is something inventory table is required in this design, right? Let's also talk in the future slides how this inventory is populated, right? So the third important schema is order DB. So order DB is nothing but it is a table which has all the information related to your bookings. Let's say you go and book a ticket, your information related to the booking is stored in the order DB, right? So if you see into that, you'll have information like order ID, user ID, train number, name, age, gender, date of birth, Aadhaar card, PNR. You'll also have seat number, state, updated time, class, purchase price, and ticket status, right? So this table is not normalized. If you want, you can normalize it, but for simplicity, I'm not normalizing it, right? So if you look into this order DB, you have to focus on two important columns, which is the state and the ticket status. Those two are really required for your distributed transactions, right? So let's talk more about when you come into that slide. So whenever you talk about system design, you need to talk about capacity planning. So capacity planning is basically estimating the hardware capacity required to build this robust system, right? So I've done a simple calculation. In this, what I've done is I took a user table, and user table has different fields like user ID, name, email, phone number, username, and password. Each and every field has a specific bytes. So I consider bytes of each field and totaled it, and it came around to 141 bytes, right? Then I also looked into the Railway Reservation website, and currently it has 54 million registered users. That means for 54 million registered users, each row is going to have 141 bytes, means totally it is going to have 7.1 gigabytes of data. That is what the current capacity of user table. And I also noticed that every day 28,000 new users are getting registered into the system. So that means every day we need 3.95 MB to be added into the capacity, right? So if you want to think about for next 1 year, how much data or how much space it has to be added, I did a simple calculation. I multiplied 3.5 into 365 and it came around 1277.5 MB. That is the total capacity required for next 1 year. So based on this, you can have a calculation for all the tables, and you can also consider the logs to build the capacity planning and to understand the capacity estimation. That's how the capacity planning is done in all the system design, right? Let's talk about the system design with microservice architecture. So you have a client. The client could be an iPhone, iPad, or a desktop, or it could be a third-party applications like makemytrip.com, right? So the client in turn connects to the load balancers, and the load balancer in turn connects to the auto scaling group, right? So auto scaling group in turn will have all your Docker containers or servers which are deployed, right? So now you can scale up or scale down the Docker containers based on the configurations in the Kubernetes, right? So you can do the scaling up and scaling down based on two configurations primarily. Basically, it is based on the CPU capacity, or it could be based on the transactions per second, right? So let's say you configure your Docker containers in such a way your capacity or CPU capacity goes beyond 70% capacity. You want to add one more machine. You can do those kind of configurations in the Kubernetes, right? So in this, you will have all your services running, right? The services can be scaled up or scaled down. That's what something we talked about it, right? So you have services like searchService, detailsService, accountService, booking service, and cancel service, right? Now let's say if you look at the search service, it has to connect to the inventory grid. So that is where you get an information related to the ticket. So inventory grid is nothing but it will have all the tickets before it has been sold, right? So now we have to populate this inventory grid with the list of new tickets or the tickets which are yet to be sold, right? So how do you do that? So basically what it does is you have a feed server which is running at different location, and it will have all your details related to the tickets, and it keeps on running during the maintenance cycle, and it goes and populates your inventory table, right? So this can be completely automated, but for simplicity, I'm just to explain, I'm having a feed server, and we are running the feed server every night to populate the inventory, right? So this is a gigantic table where you have all the information related to the ticket, right? So search service, what it does is it goes and hits the inventory table, and you can give the search parameters like the tickets, the train starting location, the train ending location, and the date you want to travel, etc. And you can get the list of tickets. That's where it lists in the search results page, right? Now you want to get the detail information of the each and every ticket. So there is already a detail service. Still you can query the inventory table if you want to get more details, and you can display in the detail service page. Let's also talk about the account service. So account service is nothing but it is going to have all the information related to the registered users. So it is in a separate database which is called as user DB. You create an account, you make sure it is authenticated, and you put all those information into the user DB. That's what we call it as a registered users, right? Now let's talk about booking service. Booking service has to connect to the order DB, where you go and book the tickets, and your ticket information after the reservation are stored in the order DB, right? So we also have internal services that could be deployed into another auto scaling group, which is not exposed directly to the customers, right? So the internal services are payment service, inventory service, notification service, right? So let's see how a booking works. Let's say if you want to go and book a ticket, now what you do is you search for a ticket, you went to the details page, then you click the ticket class, then you go into the booking section where you give all the information related to the booking, right? That information should go into the order DB, correct? So look into the green line, what it's happening, right? So now you gave all the information and you booked your ticket. So the information related to your booking goes into the order DB. We talked about two important columns in the order DB. One is state, other one is the ticket status, right? As soon as you put a booking information, you go and update into the order DB's status as pending, right? So that means your ticket is still pending, it is not booked, because you need to do other operations like payment. Then you also need to update your inventory system, right? Let's say your ticket original inventory size is like 10, now you have booked 2 tickets, it has to be made it as an 8, right? So now let's see how it happens, right? So once the booking service is called, the informations are populated into the order DB and the state is changed to pending. What happens is it gives another event to the payment service, right? So that is through the queue, right? So payment service will be listening to an event in the queue, and as soon as it gets the event, what it does is, okay, it understands a order has happened for this ticket, so now I have to do a payment transaction. So it goes to the payment get transaction and it does the payment operation, right? So once the payment is done, now the next step is we have to go and update the inventory table, right? So what happens is there is already an inventory service which is listening for another event from the payment service. So it got the information from the payment service. As you know, the payment is done. Now it goes and connects to the inventory DB and it goes and decrements the total count of the ticket, right? So now inventory is done. What is the next step? We have to notify to the customer as order has been confirmed, right? So similarly, notification service will be also listening to another event from the inventory service. So notification service, as soon as it gets the event, what it does is it goes and notifies via an SMS or via an email saying that your ticket is confirmed, right? So now all this has been done. Finally, what has to be done is your order table has to be updated as the ticket is confirmed, or it has to be updated as ticket status is complete, right? So now booking service is already listening for an event from notification service, right? So booking service will get the information, or it will get an event from the notification service, and what happens is it goes and updates the state to complete. That is how your whole flow is completed and the reservation for that is completed, right? Now at the same time, you have to see what is the ticket status. The ticket status can be two things. One is your ticket can be confirmed ticket or it can be waitlisted ticket. Now if you see everything is done and the ticket at the inventory table is available, you have to mark this as confirmed. Let's say if a ticket is not available, then let's say it goes into the waitlist state, right? So somebody can configure like, this inventory can go for a waitlist state for few tickets, right? So what happens is booking service simultaneously goes and updates the ticket status as confirmed or waitlisted based on availability of the ticket, right? That is how the whole flow works. So here the most important thing is you have to understand how the booking service works based on SAGA design pattern, right? So if you're not clear, I'm going to explain in the next screen exactly what is happening in the booking service, right? In this screen, let's talk about the distributed transactions, right? So let's focus on the booking service. So what happens here is, as I said, when the booking service, it calls the order DB, right? So what it does is it sends an event called booking created event, and the payment service will be listening for that booking created event. So once it's understand a booking created event has been happening, immediately it passes an event to the inventory service. So what inventory services, it will be listening for another event called payment process event from the payment service, right? So once that is done, it will say a payment process is done. Now let me go and update the ticket count. So it will give an information as ticket count updated event to the notification service. So notification service will be listening to that and it understands a ticket is updated. Now I have to confirm the ticket, right? So once it is confirming the ticket, again it will give an event back to the ticket confirmed event to the booking service. So booking service understands that a ticket confirmation has happened, then it will go and update the order DB, right? So now you might be asking another question, What will happen if something goes wrong? Like, let's say payment service is going wrong or inventory service is going wrong. That's where the rollback comes into the picture, right? Let's see how the rollback works. Rollback, let's say for example, if there is no inventory or the ticket is out of stock, we have to roll back. Two things has to happen. One is the booking has to be cancelled or it has to be changed to the original state. The second thing is if you have got the payment, you have to refund the payment, right? So now if you look into the booking service, it created event called booking created event. So payment service is listening to that event and it noticed that there is a booking created event which through the queue, and after that it calls the inventory service event, right? Inventory service event is listening to the payment process event. So it noticed that there is a payment process event. So now I have to go and update the ticket, right? So it went into the inventory table and noticed that there is no ticket available for that. So what happens now? It has to say the ticket is out of stock and it has to inform to the booking service. So it gives an event like ticket not available event to the booking service. Booking service which is listening to that, what immediately does is it goes and updates the state to fail in the order DB, as well as the refunding of the payment will happen, right? So in the earlier section, we talked about how distributed transaction works while doing a reservation system, right? Let's also talk about how duplicate tickets can be avoided, right? So if you look into this architecture diagram, all the information passes through a queue. That means first in, first out, correct? So at any point of time, only one record or only one row can be updated, right? So for example, if you want to update the inventory table, the information goes through the queue. So whoever is coming first will go and update the inventory table. So at any point of time, two activities on the DB cannot happen. That's how a duplicate tickets can be avoided in the queue-based microservice architecture, right? Let's also understand some of the key data from IRCTC website, right? So do you know how many registered users are in the system? It's around 53.7 million registered users. And also 28,000 new users are getting registered every day, right? Do you know how many average tickets are booked in a day? It's around 675,000 average tickets are booked in a day, right? And the other one is very important data to scale our system, right? So on an average every day, 7.2 million users gets into the system and they try for different informations like ticket information, booking the information, canceling the informations, right? All this data are based on the date June 2019. I saw this in a IRCTC website as well as BSc India website, right? These informations are really required if you want to scale our system to the level to meet the performance, to the level to meet the scalability, and to level to have a low latency, etc., right? So you have built the system designed for railway reservation system. Now you need to make sure how the system can be robust, right? So in the next video, I'm going to talk about how to build the robust system, keeping all those key points in mind, right?